Okay, here's what project number 2 looks like. You'll see there's 5 tab. Yeah, it looks like there's 6 tabs down here. But the actual work will appear in one variable statistics, linear regression, lottery, and binomial. Many different topics related to what we've done so far. Click on the project overview because this one basically takes you to this screen here where there are 4 tabs. Tab 1 is the one variable statistics right down here. It says something about that. Number 2 is the linear regression. Problem 3 is the lottery, and problem 4 is the binomial. All right. What to turn in? Well, if you do all your work in this spreadsheet, this is the only thing that you need to turn in. I'll download your Excel file and then click on each one of your tabs and see the information in there. So all of the write-up that you would do then would be inserted right here into this into this document. And how to submit it, attach the spreadsheet that you saved to your machine to an email addressed to me. And this is the day before spring break, really. So this is in 2 weeks, 2 weeks and 2 days. All right, first thing we're going to do is to go to one variable statistics. This is violent crime in the United States. This was the number of violent crimes. These were rates in the year 2019. Now, violent crimes include homicide, murder, rape, robbery, assault. Those are all, violence was perpetuated from one person to another. And so if that's the case, we call it violent crimes, as opposed to other kinds of theft where people, burglary. Burglary is something where you sneak in and you really don't come in contact with anybody. Still a crime, but it's not a violent crime. And to make sure that we could compare all of the states of the United States, each one, we have the population and we have the number of crimes that were committed, violent crimes. So you can see in the United States, about 1.2 million violent crimes occur every year. This was in the year 2019. And then if you convert it to the violent crime rate per 100,000, you get 379. So for every 100,000 people that exist in the United States, there would be 379 violent crimes committed in a year. All right, so just to see how this is created, if you take the number of violent crimes and divide by the population, you would get a rate, the violent crime rate in the population. Now, if you wanted that per 100, you'd multiply that rate by 100. But if you want the rate per 100,000, you'd have to multiply that rate by 100,000. All right, so that's how these numbers came up. And you can see, I don't know, do I have a formula here? No, it looks like they just gave me that. Okay, I'm asking you to do one variable statistics, the same thing that you do on your calculator, but do them with Excel. So here's what I want the formula to look like. And you can see that all of our data values, beginning with Alaska, we're going to analyze this single variable statistic. So that right there is in row 6, column D. So D6 going all the way down to the 50 states, ending in D55. So you need to know that range. It's like selecting that set of data to be your L1 before you push the one variable statistics L1. All right, and then there's a video up here if you want to go see how Excel deals with these formulas, but you may also want to just come in here and try something. If you want to do a formula, then you type in the equal sign, and just type in something that looks like median, like MED. Just start typing it in, and a lot of times one will come up. So here's the median function. And then you need to put your range. And the range we have is this range right here. So you can go and select it all if you want. And the only thing you want in there is calculate the median of all the numbers between D6 and D55. And if you hit enter, there you get the median. So there's the median value. Now, if I come up here and the formulas, if you put an equal sign in front of them and you put it here, it's, it won't let you type it in there. And so if you come up here and put a single quote right in front of the equal sign, single quote, that'll tell the spreadsheet that you don't want to actually calculate a formula, you're going to put in text. And so with that little single quote there in front of the equal sign, when I hit enter, it'll give me the median. So here's the formula, and here's the number for the formula. Notice if I go from here, here's the command with just the quote sign in front of it. And if I go over here, it's the same exact thing without the quote. But I'd like to see all of your formulas here. For the interquartile range, equals, we know that that's just whatever this number is, Q3, minus Q1. And then that would be the interquartile range. So you might want to do these first. Just type in equals. Boy, our calculator doesn't have a mode function. Does this one? Looks like it does. D6, D55. Oh, it actually had one. I didn't think it was going to have one. So 293 appears more than one. Yeah, get there. There it is. Here's the mode. Quartiles equals QUA. Oh, there it is. Select the bottom one. The quartile excluding the median, the quartile including the median, or just the standard quartile function. All right, so we want to calculate the quartile from D6 to D55. Now you need to put another input here, because you've got the list of numbers of your data set here, but then you need to be able to specify the difference between the first quartile and the third quartile. So if you want the first quartile, you put a 1 there. And if you want the third quartile, you'd put a 3. And it gives you the quartile. For the upper fence, you want to take the third quartile and then add to that 1.5 times the interquartile range, which is whatever is there. Now it's not going to record anything now because we don't have anything in the interquartile range. Although, what does this say? I-16. All right, so this pretty much is just to enter in all the formulas, enter in all the corresponding values, and then come down here and write your summary statement. Now, when you're doing the summary statement of the violent crime rates, you could just go right through the several of the statistics that you calculated above and just say what they mean. The average crime rate in the United States is 365 crimes per 100,000 in the population. The largest crime rate in the United States is Alaska, where it has 867 crimes per 100,000 in the population. The smallest crime rate is Maine. Maine only has 115.2 violent crimes per 100,000 in the population. We would say that you're more than, 115 times about 7. You're about 7 times more likely to be the victim of a violent crime in Alaska than you are in Maine. You could talk about the range of the values. You can talk about the quartiles, interpret the middle 50% of all the crime rates fall within. So if you could interpret each one of these in the context of crime rates, you would have a pretty good interpretation, a pretty good description of the data set. So say a few sentences down here. Single variable statistics. So this would be related to, what we did in chapter 3. And that's it. All right, the next one is linear regression. I provided a graph here. This is just a picture. And you can see each one of these represents a state, each one of these bubbles. It's called a bubble plot. And the bubble plot really is a scatter plot, but we add one more variable, and the variable that we're adding is the size of the bubble. So the bigger the size of the bubble, the bigger the whatever it is we're measuring. In this case, it's population. So you can see California is the biggest bubble. It has the largest population. Texas is pretty big. And, down here is New York, this one. Vermont is that real tiny one right there. And I just drew these leader lines in there. Title, the meaning of the vertical axis, the meaning of the horizontal axis. And I want you to throw in your line of best fit and then the correlation coefficient on the graph as well. And the correlation coefficient here is the correlation coefficient that relates the property crime rate, the x-axis variable, and the motor vehicle theft rate. So again, we're down into crime statistics. So I think I'm using the same exact set of data for this one. Okay, so you can see, let's see, we have violent crimes here. That's what we used in the first problem. In this one, we're using population. This is going to be your bubble size here. So look at these cells. It's in B10 down to B some larger number. And we're using the property crime rate. Okay, property crime rate. We're using these numbers. So I shaded in yellow the data that we're using. And if you go over a little further, these are the motor vehicle theft rates in here. So the 3 yellow columns are the columns that you're going to use for this graph. Now I copied those 3 columns along with the name of the state, and I put it down here. So I grabbed those numbers so that they were all close. So now what we're going to do is we're going to, well, let me just take the crime rate and vehicle rate. If I just took these two and highlighted both lists, you did this in your first project, and then you come in here and you insert a scatter plot like this, that pretty much is this graph. See how it goes up like this? Yeah. All right, now just imagine that we introduce the population variable and we increase the size of these little dots to reflect the population size, where bigger dots would be, or bigger bubbles would be the bigger states in population size, and the smaller points, bubbles, will be the smaller states. So I have to go and select one more. Let's see if I can just drag this over. No, it's not allowing me to do it. All right, let's get rid of this graph. This is not the one we want. Oh, by the way, if you had this in here and you wanted to come up here and insert a chart element, down here's the trend line. And you'll want to insert a trend line that's linear. And now you can see it. I don't know if you can see it very well, but you can see it. I'll make it larger. Here's the trend line. And then if you click on the trend line, and then you either right click or control click, you can format that trend line. And when the options come up over here, you can display the equation on the chart. And you can display R squared. Now we don't want R squared, but we want R. So if they do calculate, if you do want to put R squared, you can just come in here. I'm going to enlarge this a little bit so you can see it better. I'll go up to 16. So there's the equation of that line, and this is the R squared. So you'll want to replace the R squared with with R, the correlation coefficient. And as you might have guessed, it's just the square root of the R squared that they gave you there. So insert that value in there. I don't remember what it was, something like 0.85. But I'd like to see this on there somewhere. Your title should be on here. You should label this axis with the appropriate unit. So click on there, add a chart element, axis title, primary vertical, and then come in here and click the meaning of that one. And then insert a chart element, axis title, primary horizontal, come down here, click on that one, change the axis title to something more meaningful. All right, this is not the graph we want. So let's highlight the population numbers as well. All right, so I think this is set up so it always plots the X's and the Y's and the bubble sizes in this order. So if you want to move the populations over here and then select them, you can do that. I'm going to do it this way because I want to change the data manually. All right, with this highlighted, I'm now going to insert a graph. And here's where I found the scatter plot. But if I click on that, notice down here, you've got the bubbles. So I'm going to click on this one. And it's clearly not something that I want. Okay, so I'm going to go in here, just click anywhere in the graph. Again, either right click if you have a PC or control click if you have a Macintosh. And I'm going to select the data. All right, my X values, I want to be the numbers in column C. So I'm going to click on this, and instead of the B's, I want the C's. C63 to C112. For the Y values, I want the numbers in column D. So I'm going to change these C's to D's. And then the bubble sizes, the sizes, I want those to be the populations, and then the populations appear in column B. So I'm going to change these D's to B's. So populations are in B, the X-axis variable in C, and the Y-axis variable in D. All right, I think that's what I want. So now I'm going to just hit OK. And then there you see something that kind of looks like my graph. All right, I'm just going to do a couple of things just so you can see how you would make your graph similar to mine. One of the things, we've got a lot of open space over here. So I'm going to go start this graph at 1,000 and maybe go over to like 3,300. So I'm going to click on this axis. And again, whenever you want to edit something, you either right click or control click. And I'm going to change this from 0, and I'll just start it at 1,000. And then maybe I'll go up to 3,200. Let's see what that does. Well, maybe 3,300. I don't want to cut off that last bubble. All right, so you get some space here. That's good. When you click on these bubbles and then right click, you can add a data label. I don't like that data label, so I'm going to click on that data label and then control click again so I can format that data label. And then instead of adding the Y value that I don't want, oops, I guess I don't want to do that. Let's try it again. So we want to add the data label, and then we want to format that data label. All right, now I want to add a value from the cells, and I want to add the populations. Not the populations, but the names of the states. So let's see here. I'm going to go select all the states from Vermont up to, hopefully that's a state there. Yeah, that there. All right, good. Okay. Then it puts the states in there. Now I don't want this Y value because the only thing I want is the state. And then you can move these around however you like. And when you move it around, it'll give you a leader line. So if things are all crowded in there, you can move them around to label the individual states. All right, I'm going to click on the bubble and then right click again, and I'm going to format the data series this time. And one of the things I like to do with this one is the bubbles are too big. And so I'll adjust the bubble scale to half its original size. And you can see it creates more space, more white space, that then allows me to drag these states around. The other thing I like to do when I, again, click on and format the data series is it allows me, when I come up here to the paint can, it allows me to vary the colors of the bubbles. And so you can see you get a different color on all of those. All right, I think this is what I had. So what else would you have to do? You'd have to add the vertical axis scale. You'd have to add the horizontal axis scale. You need to add your trend line and then label it and then put in a title and then just move around these guys here. Okay, I'm going to continue to talk, but we are at the end of our time. And so if you need to check out right now, you can go ahead and check out of the class because it's right at 1:55. I'm going to go through the binomial and the lottery, these last two pieces. And if you can't be here, then I'll make a video this afternoon, and everything I'm talking about right here, I'll put up on that video so you can go and watch it, you know, or not. You don't have to watch it, but it'll be available. So if you need to check out, that's fine. You can check out now and just come back to e-learning where you'll see a link to this video. I'll call it, you know, video for project 2 or something like that. Okay. For those yeah, go ahead.
So you said that you wanted this downloaded.
Yeah.
But before we did take like screenshots of the graphs. Is that something that you want, or is this completely different?
No, for this one, you're going to be doing all your work and your descriptions and so on actually in the spreadsheet. So once you get the spreadsheet the way you like it, with, you know, you've got a couple of graphs like this one that you're constructing, and you'll see later on there's some other things that I ask you to include, and everything's going to be done on the spreadsheet. So there's no real screenshots you need to do.
Okay.
You just once you get everything done, just save your Excel file and then just attach the Excel file. And that's it.
Thank you.
I'll open it up and I'll see all your work. Okay. Yeah, so just again down here, we can come up, hit the chart design, and then add chart element. You can add the trend line, a linear trend line, and you can see the same line goes up there. But it's the trend line between the X and the Y. Click on the line, and then right click or control click to format the line. And what you might want to do here is to display the equation and the R squared on there. This is always going to be too small. So when you go to the home screen or the home menu, you can, I like going up to about 16, but you can do whatever you want. These numbers over here, again, too small at a 9-point font, so you might want to raise those again as well. So increase the fonts all around. Even these states, if you click on these states, there we go. You can even increase their font to 16 to make them look a little bigger. All right. Can't see anything on this graph, but if you start dragging these guys away to kind of put them on the away from the line of best fit, at least you know, you got a lot of room up here that you can play around with. Okay, and so let's go on to the next one, the lottery. By the way, this problem right here would be a problem from, say, chapter 4.1 and 4.2, where you were plotting a scatter plot and then drawing the line of best fit and then using it to make predictions. So the only thing that I want here is the graph. All right, let's go to the lottery. The lottery is related to section 6.1. And what I want you to do is, if you look down here, there's another ticket, the Connecticut ticket down here. So if I click on that, you'll see here's a sample lottery ticket. And I'd like you to look at this lottery ticket and look at all of its features, and down here are all the features, and then go through each one of the features and say how your ticket is different from the Connecticut ticket. Generally, this is an expected value problem. And what you're going to do is you're going to design an instant lottery ticket. It's one of those tickets that you buy at 7-Eleven or convenience store. You pay $2 or $1 or even $20, and then you scratch them off. And then when you scratch them off, it reveals your prize. Well, these tickets have to be created so that consumers will actually want to buy them. And so, for example, this number over here is the probability of winning. Now, you don't want the probability of winning to be 0.0005, because that means, you know, someone's going to buy these tickets and they're going to have only a 5 in 10,000 chance to win. And nobody would play because the odds have to be posted by law. And so when you design your lottery ticket, you want this number to be greater than 0.25. And all the criteria for your ticket are down here, and they're color coded. So for example, this one here is in salmon color or pinkish. The probability of winning must be greater than 0.25. So here's the pink stuff. The cost to purchase your lottery ticket must be a whole number amount less than 26, such as 1, 2, 3, up to 25. So the first thing you're going to do is you're going to type in your ticket cost right here. So let's say that you wanted a ticket that costs $10. Notice the spreadsheet is set up so that if you change some of these cells, all of these other things will change as well. Like, look at the expected value. Now, the expected value down here in blue, we want that number to be the expected loss to a consumer to be less than $1. So if someone's going to play this game and every time they make a $10 bet, they're going to lose $7, they won't play it. It's just too much to lose every time they play. The value for playing, you're going to lose a lot of money very quickly. So we want this number, even though they're spending $10 per ticket, we want it to be less than $1. We don't want them to lose more than $1 every time they play. That's going to keep them coming back. All right. So you decide what the prize amounts were. The first one's going to be a 0. This is going to be the loser. Somebody buys this. You can see 6 million tickets of the 9.5 million tickets are losers. Now I have this cell set up so that it's a formula. So don't change this one, just change these down here. So for example, if I change this 3,000 to 2,000, when I hit enter, look at what happens to this one here. It changes. And it changes so that the number of tickets sold every time is 9.5 million. And that's one of the requirements down here. There must be 9.5 million tickets sold. So these formulas are set up so that the sum of all these tickets will add up to 9.5 million every single time. So you don't have to, you know, increase this one by 1 million and then decrease this one by 1 million. You can just change one number and everything automatically updates. These are the prize amounts. You always want the first prize here to equal the ticket price. So if you're going to have a ticket price of $10, you want this first prize to be $10. And then everything else, every other ticket after that should be more than this. I mean, the idea is that you don't want to sell someone a $10 ticket and then give them a prize of $5. Well, you won $5, but you actually lost $5 because you had to pay 10 up front. Okay. The grand prize must be 300,000. Right now it's sitting at 200,000. So I have to change this one to 300,000. That's going to change all the other numbers. All right, so you get to play around with all these prize amounts, and you get to play around with all these number of tickets. So these are the only numbers that you should be changing on this spreadsheet. These two, and of course the ticket price. These two and the ticket price. Because once you change these, all these other ones would change. Okay, we notice that we have, and here's how you can change. What I would recommend is I would say, okay, what if I increase this to 3 million instead of 2 million? Look what happens in each case to the profit. See, the state right now is making $65 million. And you only need the state to make more than $7 million. That's one of the criteria. See in gray here? The state must make a profit of more than 7 million. Now, this number is okay because it's more than 7 million, but I think you'll find that if you want to meet all the other conditions of the problem, that you're going to have to lower the profit a little bit. Well, one way we can lower the profit is to create more winners. So let me change this 2 million to 3 million. All right, now when I hit enter, look what happens to this number up here. We've already seen how that would change. Look what happens to the profit. I mean, if we're giving 1 million tickets of $10, we're giving away an additional $10 million. So this profit's going to go down by 10 million. The probability of winning, is that going to change at all? It should. I mean, you're creating more winners, so the probability of winning should go up. And then what's going to happen to this expected value? It's way too high right now. All right, so let's watch when I hit. Right now, the expected value is $7.11. So when I hit enter, notice how it lowered it. It's still too high. Probability of winning, good. Profit of more than 7,000, good. Grand prize, 300,000, good. 9.5 million tickets, good. But this one here is not good, and you want all the conditions to be good. This will be the most important one. So what you could do then is you could say, well, what happens if I increase a prize amount from 1,000 to 10,000? When I hit enter here, we're given 10,000 tickets, or 1,000 tickets at a much higher rate, so that's going to lower our profit. We're not changing the number of tickets, so it's not going to change the probability of winning. But if we change this dollar amount here, what's going to happen to this number here? There it goes. Changed it very little, if at all. All right, so you kind of get the sense of what you need to do. If you're unsure what you need to do, then just try experimenting with a couple of these. What if I change this and increase this prize amount? What's going to change? Will I increase the prize amount? The expected value goes down. Well, change it again. 20,000. Profit goes down, expected value goes down. Well, maybe if I did 5,000 here. Every time you make a change, all of these updates, I've already got it down to 4.94. So think to yourself, how do I lower this to get it less than $1? Do I change one of these or more than one of these? Can I change one of these and would that do anything? We still have a large profit, so we still have a lot of money to work with. So this is going to be trial and error. There's no, correct way, but you can figure out what the best numbers to change are to get to where you want to be. So as long as you've satisfied all of these 1, 2, 3, 4, 5, 6, 7 criteria, everybody's going to have a different ticket. Nobody's going to have the same one. As long as you satisfy those conditions, your ticket would be fine. And so notice you have to enter the selling price. We did that. Enter the prize amounts. We were doing this so that everything matches. And then the last thing is to enter a response here to compare your ticket to the Connecticut ticket. We talked about that at the beginning. So just compare the two tickets on the, the grand prize. The grand prize of the Connecticut ticket is 500. Your ticket is 300,000. Which one is the consumer more likely to buy? The odds of the Connecticut ticket of winning are this. The odds of winning my ticket, this new ticket, are this. Which one are the consumers more likely to play? The expected value for the Connecticut ticket is this. The expected value for the new ticket is this. Which one are the consumers more likely to play? Okay, so that's the lottery ticket. That's from 6-1. And then the last one is the binomial. And what I've done here is I've created a spreadsheet so that you identify a value of n, say 60, and then you select a value of P, a probability value in the binomial. And let's say that we do 0.7. Notice when I hit 0.7 and I put enter here, what happens to Q? What happens to this one? So there's a formula in there that takes 1 minus P to get the Q. That's all set. It gives you the mean and the standard deviation. And then notice that N is equal to 60. So the possible values of K go all the way down to 60. Anything after 60 just gives you garbage. So you can ignore all that. Now what's in the rest of these columns? Well, all right, so for this one, if I wanted the probability that X is equal to 19, I would have to change my N to 60, my P, I think it was 0.7, and then the X value is 19. So what I wanted you to do here is I want you to go find this probability in the table. So with N is equal to 60 and P is equal to 0.7, all the tables in this value are based on that. And then we want to go down to X is equal to 19. Well, right there it is. And so rounded to, yeah, it's basically 0 rounded to 5 decimal places. If we want to see more, then we'd have to extend the number of decimals. It's pretty small. Yeah, there it is. 1 in 10 million maybe, but it's a very tiny number. So I'm asking you just to round these to the nearest 5 decimal places. So you'd have to put 0, 0. Then notice this is shaded in blue. Come over here and shade where the answer is in blue. For one like this, X is less than 25. Well, that would take all the values from 0 up to 25, not including 25. And so for this one, let me shade this one here in maybe green. Nope, already got green. Let me shade it in salmon color. All right, so less than probability, less than 25. Here you see the less than probability. Go down to 25. There it is again. So I can extend that one a little bit. All right, and so then I would enter 0.000005. And then what I would have to type in here is binomial, and you can actually do this with your calculator, right? But instead of binomial PDF this time, since it's a less than probability, we want binomial CDF, and we want that last number to be 24. So I want you to link what the Excel spreadsheet is doing to the correct formula here. And for a greater than 21, there's the greater than column. Let's do greater than or equal to. Greater than or equal to, that's this column here, 41. Let's shade this one in maybe blue. Again, now we want blue, we've already got blue. How about yellow or orange, whatever that is. So it's greater than or equal to 41. So I have to go down to row 41, right here, all the way over. That one right there. And I'm going to shade it with that color. So 66916. And then for this one, you would need to type in, since it's a greater than probability, 1 minus binomial CDF 60.7. And then the last value that we're not going to add is 40. All right. And then if you check this on your calculator, you should get the same exact answer as we got here. All right, so basically for this one, I want you to select your own value of N, select your own value of P. So nobody's going to have the same table. Nobody's going to have the same answers. And then complete this table. Write down the calculator formula that you used, and then write down the probabilities from the table that you can find in here. Doesn't look like I did this one. Less than, it's this one here, 25, and we want that to be pink. There it is. So that I can see your blue, pink, orange, color coded here with the same exact values. So yeah, that's it. That's the final part of the project. So working with the binomial, seeing how the Excel can do the binomial functions. If you want to know what those binomial functions look like, you can just click in here to see the formula. It uses binomial distribution, and then it asks for n and p, and I think these two, this would be your n, and this would be your p, and then this would be the specific x value. So it's in a different order. And then this last thing here, it's false if you don't want a cumulative probability. So this would be like normal PDF. When we go to these over here, we're going to have true because we want to do a cumulative probability. All right. So binomial, then expected value with the lottery ticket. And then linear regression, where you're creating this bubble plot, and then single variable statistics in Excel.